All right, in this video, we're going to be talking about a couple of the most basic terms in the motion of objects. We're going to start with an object's position, which sounds very self-explanatory, but we need to be very deliberate about these things so that we actually can use these terms correctly later on. So what does the position of an object actually mean? First of all, position is a vector. Like I talked about in previous video, that means that it has both a magnitude and a direction associated with it, which might surprise you a little bit. But maybe it shouldn't surprise you, because the way we're used to thinking about position mathematically is like the position, for instance, could be positive or negative. That's like what we're talking about here. Where is it? Is it to my right? Is it to my left? That's a direction. So the position is a vector which points from the origin of your coordinate system. So like, for instance, let's say that the origin is my own body, my own personal position. Like I was saying, I might say this, whatever, this pen is to my right. So it's a vector which, imagine, pointing out from me to the location of the pen. And that's the position vector. So it comes from the origin of where you're measuring things from to the object's location. So it's a vector which points from the origin to the object's location. That means that the magnitude, which remember is basically the size of the position vector, is its distance from the origin. So how far is the pen away from me? That's the magnitude of its position. And the direction is which way it is located from the origin. So that's the position. Normally, we denote the position with a vector like x. And when I make that symbol above a algebraic variable, that symbol, sometimes people write it that way, or sometimes people use a full-on arrow like that, or sometimes in typeface, people will bold it, something like that. That indicates that that quantity is a vector quantity, just to remind you that this is a vector. So that's the meaning. So let me draw it. Okay. So let's say we have an object, like here's an object, okay? And I want to know what is the position of that object on my screen right now. How do I unambiguously and quantitatively describe what is the position of that object on the screen? So the way I'm proposing to do it right now is, first of all, you're going to need a reference point to measure it from. So let's say I draw an XY coordinate system like that. What we're doing here is, starting from the origin of the coordinate system, we're drawing a vector that points to the object's location. We're measuring the length of this vector. That is the magnitude. So that's the magnitude of the position. And then this has some angle here, which would give you the direction of the position vector. So it has a magnitude and direction. Another way to think about this is that it has an x coordinate and a y coordinate, which is similar information. I'll come back later to the connection between these different ways of describing it. But that's how we describe the position of an object. Okay. Now, a closely related concept, get rid of some of this. A closely related concept is called the displacement of an object. And this is one that's actually going to be more practical a lot of the time for us. So the displacement of an object. Displacement is a vector which points from an object's position at an earlier time to its position at a later time. So now we're basically introducing the idea that some amount of time has elapsed between like an initial state and a final state, and the object was at one location in the initial state, it was in a different location in the final state, and we want to kind of now ask this question of like, how far did it move in that time interval? That's sort of what the displacement is asking about. So let me do the picture first. So what I've drawn here, imagine that this is the object's initial position. So let's denote it as, for instance, x subscript 0. The subscript 0 means that's the initial position of where the object was at the beginning of this process. Now, let's say that the object maybe is down here at a later point in time. Okay. The object also has a final position vector, which would be this one. The position vector always starts from the origin, remember. So this would be the object's final position vector. But what about the displacement? The displacement vector points from the object's position at the earlier time to its position at the later time. So in other words, the displacement vector points from here to here. So this in blue, this is the displacement vector. Okay, so a few things to notice about that. First of all, the magnitude is how far the object is from where it started. The direction is which direction did it move from where it started. And most kind of importantly and most counterintuitively about the displacement, displacement only depends on where it starts and where it ends, does not depend on the actual path taken by the object. So we do not, I'm not making any statement in my picture here about where the object actually went between the black state and the red state there. It might have moved in a straight line directly along the displacement vector. It might have done some crazy path where it went who knows where, millions of miles away, and then come all the way back and ended up a few inches from where it started. Doesn't matter. The displacement vector does not tell you how far the object actually moved during that interval. You write this down as well. Okay. Displacement does not tell you how far it actually moved during this interval, only how far it is from where it started. So we're not making any statement about the path that the object took or the history of what the object did. We're only making a statement about where it is now compared to where it is at the beginning, the final result. If you do want information about how far the object actually moved, the correct thing to use would be, there's another quantity called distance. The distance traveled by the object is the actual amount that it moved between the initial and final states. So distance has a distinct meaning from displacement. Displacement, first of all, is a vector. Distance is not. Distance is just a number. And then second of all, displacement goes directly from the initial to the final state. Doesn't matter what path the object actually took. On the other hand, distance traveled actually does consider the whole history of the object from the initial state to the final state, and we'll actually try to measure the length of the path that the object took to get from here to there. So that's a distinction.